Yeah. I tried to find some headphones, but for whatever reason, for my work laptop, I can't plug headphones into it. I don't know. I'm gonna have to work it out. So if there's like some feedback, yeah, I don't know. I'll try to work on it next time. So here's the question: find the series, interval, and convergence, and within this interval, the sum of the series is a function of x. So, let me pull up Word here. Okay. Anytime they're asking you to do interval of convergence with these power series, you're pretty much automatically going to do ratio tests. You could probably do root tests for this one just because you have those powers to the n, but ratio tests always work. Well, I don't want to say always, but 99% of the time it's going to work. With the ratio test, this is where you're going to take the limit of that absolute value of the n plus 1 term divided by the nth term. So the n plus 1 term you have to be a little bit careful about because you are going to have to distribute that 2 into the exponent up top. Divided by 4 to the n plus 1. So instead of dividing it, I'm just going to go ahead and multiply it by the reciprocal. So we're dividing it by the nth term, which is the same thing as multiplying it by the reciprocal of the nth term. So 4 to the n divided by x minus 1 to the 2n. Okay. So now what we want to do is we're going to use some of the powers of exponents. We'd have to distribute this 2 into the parentheses. That is going to be, so we still have the x minus 1, and now it's going to be to the 2n plus 2 power. With this denominator down here, this 4 to the n plus 1, that I would rewrite as just 4 to the n times 4 to the 1. The other stuff I would leave alone. So the fraction there on the right, just leave that alone. Okay. The point of doing this is now a lot of things cancel out. This 4 to the n cancels out with this 4 to the n. This we would rewrite as x minus 1 to the 2n, and then we would have an x minus 1 squared. The x minus 1 to the 2n would cancel out on top and bottom. So it looks like all we have left is still at the limit. We're going to have an x minus 1 squared floating around, and then in the denominator we just have a single 4 because the 4 to the n cancel out. There's no more n's that are left over, and that's where your limit was going. Your limit is going from n to infinity. So this is just a constant with respect to n, which means we can drop the limit at this point, and it's just that x minus 1 squared all divided by 4. Okay. Remember that that's going to be our p-value. So that means that the p-value for the ratio test is this absolute value. And what we want to get convergence is that for the ratio test, we want that p-value to be less than 1. So here we're just going to set that absolute value to be less than 1. And anytime you set an absolute value to be less than 1 or less than anything, this is where you want to squeeze. So now we can drop the absolute value, and we're going to squeeze that term there between -1 and +1. We can multiply both sides by 4. Here, it's a little bit tricky, kind of, because when you take the square root, you have to worry about pluses and minuses and things like that. So another way of thinking about this is that x minus 1 squared can never be negative anyway. So really what you have is that x minus 1 squared is just less than 4 and greater than 0. So you're taking the square root of that. So you're going to get 0 is less than just x minus 1 is less than 2. So I know that's kind of a weird part there with these inequalities, but inequalities can get kind of strange, especially when you're doing stuff like square root, and then here with absolute values, that squeeze things a little bit strange too. I forgot the plus and the minus, right? So really it's plus and minus 2. And the minus 2 is now going to come over to the other side. So I just double check in my head to make sure that makes sense. Okay. And now add the 1 everywhere. Okay. So once we have the interval like this, now we have to test the endpoint. So we'll test x to be equal to -1 first. So when x is equal to -1, this is where we want to plug -1 back into the original sequence, or series here. So if I plug -1 into this, we're going to end up with -1 minus 1 to the 2n divided by 4 to the n. So -1 minus 1, that's a -2. And then we could use some of the rules of exponents here. We can go ahead and square it to get rid of that 2 as an exponent there. So it's going to be -2 squared, which is +4. So we're going to have a +4 to the n on top and a +4 to the n on the bottom, which is just 1. What this means for us is that we're taking that infinite series as n goes from infinity of just a constant 1, which is 1 plus 1 plus 1 plus 1 forever and ever and ever, which definitely diverges. We'd have to test the other endpoint, x to be 3. So if we plug x to be 3 into the original series here, we would have 3 minus 1 to the 2n all divided by 4 to the n. That's going to be 2 to the 2n, which is the same thing as 4 to the n divided by 4 to the n again, which is the same thing as we just had up there. So this also diverges, which means that this interval as is going to be the answer here. Our interval of convergence is between -1 and 3. Okay. Then it asks you for the sum of the series. Any question that you ever have, if they ask you for the actual sum, it has to be geometric series. So this is going to be a geometric series question. We just have to write it in that geometric series form. To do that, I'm going to combine some of these exponents together. I'm going to rewrite this x minus 1 to the 2n a little bit. I'm going to write it as x minus 1 squared, and then that whole thing to the n power. If the computer lets me do it. Well, I tried. Yeah, that's close enough, right? Just imagine that the sum is out in front. So the sum of x minus 1 squared all to the n, which means that now that they're both to the n power, we can combine them together inside of the same exponent. So the sum of just x minus 1 squared divided by 4, and then that whole thing to the n. That looks nice. So this is going to be my a and my r value for the geometric series. The a value is just going to be 1, that coefficient that's in front of the thing that's to the power of n. My r value is going to be this other thing, this x minus 1 squared divided by 4. And remember that as long as this is less than 1, it converges, but we already did that step. That's not the step that we're trying to do. We're trying to figure out convergence, or where it converges. And remember, for geometric series, this is the formula for where it converges. It converges to a divided by 1 minus r. So just plugging in what we have, that's going to be 1 divided by 1 minus this x minus 1 squared over 4 thing. It looks really awful, and it kind of is. You just have to fix it. So just multiply 4 on top and bottom everywhere. You could probably just leave it like this and type it in. I imagine it would give you the right answer. We'll try it. Is that what I had? 4 over... Yeah. So I would just leave it like that. You could multiply out the x minus 1 squared here and then combine like terms together, but it's not going to look any nicer than what we ended up with there. So this x minus 1 to the 2n over 4 to the n converges to that. Does that make sense? Does that help?
Yeah, that does. Thank you.
Cool. Oh, we lost Josh. But we gained Nick. Hi, Nick.
I've got a question. It's not necessarily a homework question per se, but it's a method question.
Okay.
So not for the N series, the nth term test per se, but if you have like something to the nth exponent, and if you use the nth term test, how does that compare to a factorial or like just 3n versus 3 to the n? Like how would you go about plugging that infinity in?
Well, if it's just like a constant to the n,
Yeah.
like that, I mean, that blows up to infinity when you plug infinity into it.
Okay.
As far as comparing it to n factorial, 2 to the n is slower than n factorial.
Okay.
Yeah, but 3 to the n is faster than 2 to the n, 4 to the n is faster than 3 to the n, and so on and so forth.
Okay, because I know that when we use the nth term test, we compare either the coefficients of the n terms to determine once we use the Hopital's rule to determine whatever we have to find. But how do we compare the exponent of n? So if you have to the n, like that.
If you have this is going to go to 0.
Okay.
It goes to 0 because n factorial gets bigger way faster than 2 to the n gets bigger.
What if it's 2 to the n over 3n?
Like that?
Oh, just 3n, not the exponent, just 3n generally.
Okay, yeah, so for this one's going to blow up to infinity.
Okay, got it. Okay.
So it blows up to infinity because, again, like 2 to the n, if you were to plug a big number into that, it explodes.
Mm-hmm.
But 3 to the n is just a linear term. You kind of want to think of it like the graph a little bit too. Let's see if I can get a thing going here.
So if you can't compare like n squared to n cubed or something, then it's just whichever function or whichever part blows up faster to determine either 0 or infinity or whatever.
Yeah, exactly. It's just kind of like, if you want to think of it like how the graph end behavior is. So 3 to the n is just a line, right? But 2 to the n, it's like silly, it goes up like that, right? It's an exponentially increasing thing.
Yep.
So because this blows up to infinity faster than this, it has to go to infinity.
Okay. Gotcha. I understood the comparison, just on a couple of questions I got just confused on myself, so thank you, sir.
Sure.
Okay.
Any other homework questions you guys want to look at? I did take the chapter 10 test this morning. I'm a little bit worried about it. I don't know how an online test is going to go for series and sequence stuff.
So like when we open the test, right, it's gonna like prompt us with the browser lockdown thing. Like we don't have to like go off on Moodle and download it. It'll just prompt us, right?
Yeah, no, it's as soon as you go to open the test, it'll just say, do you want to download the lockdown browser? And you just hit yes, and then it just does it right away.
Okay, cool. And you said a lot of the questions are gonna come from like the 10.7, 10.8, right?
Well, you know what I thought it was going to be? But when I made the test, it was a fairly even distribution between everything. So when I went through it, there's not too much coming from section 1, but section 2, like there was the nth term stuff, and there was a couple of definition stuff from section 2. You're definitely going to have some integral stuff. So I think there was like 2 or so questions from 10.3, the integral stuff questions. 10.4, there's not too much there. That's that limit comparison test stuff. 10.5, what was 10.5? The ratio test and the root test, that you have a lot from alternating series, kind of, and then you have, a lot from 7 and 8. But I wouldn't say it's as overwhelming as I made it out to be the last time.
Okay.
I would just go back and look through like every single section, and review kind of all the different topics. And then that file that I gave you guys with all the different tests, just make sure you kind of have that with you and on hand when you take the test.
Yeah, I printed that out yesterday.
So did I, yeah.
Yeah, make sure, that's a good idea. So for those of you watching the video later, print it out, because I don't know if your lockdown browser will let you open it up when you're taking the test.
I've got another question.
Sure.
So for instance, if we have 3 to the n plus 1, like 3 to the n and then plus 1 over the n. 3 to the n, yeah, plus 1 over 4 to the n. And we're using the nth term test. But what would happen?
It goes to 0 for this one too.
Okay, why?
So this one would go to 0 because 4 to the n blows up faster than 3 to the n. Adding and subtracting numbers does not affect the end behavior of a function, like at all. So you can pretty much just drop any adding or subtracting. This is really the same thing as 3 to the n over 4 to the n.
Okay. Gotcha.
If all else fails, just plug in big numbers. Like if I wanted to plug in maybe n to be 100 or something like that. So I don't have a calculator in front of me. In the computer. So 3 to the 100 power, some awfully big number, and then 4. So this is to the 47th power. This is to the 60th power. All right, so you're going to get the top number is something 1 times 10 to the 47th, right? So it's got 47 places to it, but the denominator came out to have, I forget what it was, but like 64 places to it.
Okay.
As like a number, a factor or whatever, this thing has 20 some odd more place values to it. So just imagine that this denominator number is trillions of times bigger than the top number, which means the denominator is getting to infinity faster, so the whole thing goes to 0.
Okay, that makes complete sense. I just continue to get confused because I kept wanting to do the ratio of the coefficients, and then I'm like, oh, this is the exponent, so it's not going to work that way, but then again, it's just whatever blows up faster, so. Okay, thank you. That makes complete sense.
Yeah, the only time you want to look at the coefficients is when you have polynomials, and if they're the same degree. Otherwise, don't look at that at all.
Okay. Perfect. Thank you, sir.
Mm-hmm.
Can we do on 10.8, number 5?
Yes. Okay, yeah, so it's asking us to find the Maclaurin series for 5e to the negative x. The Maclaurin series is just a Taylor series. So really that's all we're doing. To do this, you would need to have the formula in front of you for Taylor or Maclaurin series, and it's this. So it is the case derivative. The Maclaurin series is always going to be at 0 divided by k factorial, and then it's x minus 0, so just x to the k. I think that's on that sheet that I gave you guys as well. If not, make sure you write it on there. So what we have to do is that if we're given our function f of x is at 5e to the negative x, we need to keep taking the derivative until we come up with a generic way of writing out what the derivative is for any particular derivative. So just the function itself is 5e to the negative x, but then the first derivative, and I'll just do a few of these, would be negative 5e to the negative x. The second derivative, just bringing down another negative sign, 5e to the negative x. Maybe one more. Third derivative would be negative 5. Now, remember, we don't really care about the derivatives necessarily. We care about what happens when we plug in our value. Here we're plugging in 0. So if I plug 0 into just the function itself, it's going to be 5e to the 0, which is just 5. Into the first derivative, we're going to get that, the coefficient out in front, negative 5, and then positive 5, negative 5. And it looks like it's just going to alternate back and forth, 5, negative 5, 5, negative 5. So what that means for us is that we can go ahead and define what f sub k is at 0. It looks like this is just going to alternate. So we're going to have a negative 1 to the k. That's what makes it alternate back and forth. And then just a constant of 5. So now if we plug that in to my Taylor series up there, we're going to have the negative 1 to the k times 5. That's going to be divided by the k factorial and then times x to the k. And I don't think there's anything else we can do to this. I think we're just kind of stuck with it as is. And I think that's what the homework's going to want here. So negative 1 to the k times 5 divided by k factorial, and that times x to the k. Oh no, I didn't like it. Oh, that's because I should have been using int. There we go. And so the hardest part for these questions is just figuring out how to write your derivatives as its own kind of sequence value. But you don't have to do that for every question. If only when they want you to write it out like this, a lot of the times the questions are just going to want you to write out that Taylor polynomial thing. So the piece of n. Right. So just be plugging in like the terms. So the first one would just be 5, and then minus 5x, and then plus 5 halves x squared, and so on and so forth. Like you just have to plug in all these different x values to figure them out.
Okay, thank you.
And some of these things get kind of hard, so make sure you're really, like on the homeworks, writing it all out. I think on that video I made, like I kind of skipped over the cosine and the sine ones, just because those derivatives are kind of awful, but make sure you're looking at those anyway. Any other homework ones you want to look at?
I think I'm good right now.
Okay.
So am I.
Oh, cool. We gain any more people? Josh, you're back. Josh, you got any homework questions? Oh, can you hear us? Did you hear us before we were answering about the test thing? I'll send it out as a PDF, and hopefully you can open up then. 10.8, number 3. Yeah, we can do that one. All right, so for this one, find the Taylor polynomials of order 0, 1, 2, and 3 generated by f at x equals a, where f, we're given the function 1 over x and a is x3. Okay. Same thing here, but this time we're going to be doing the actual Taylor series one and not the Maclaurin series. So for that one, that's going to be, not to the negative one, sorry. F to the k, the kth derivative, at our value 3, divided by that k factorial times x minus 3, all to the k. So just a more generic way, where here we're centered at 3 instead of being centered at 0. So we are going to have to do the derivative multiple times. So just the original function as is 1 over x. We'll take the derivative once, which is negative x to the negative 2. Take the derivative again, which would be positive 2x to the negative 3. Maybe one more time. Negative 6 x to the negative 4. Okay, so you would just have to see the pattern here. And I remember at the beginning of chapter 10, this was the stuff that people didn't really like, of looking at the pattern and writing out what it would be generically. Luckily for this one, you wouldn't have to do that because it's not asking you for the entire series. It's only asking you for these polynomials, which is the first few terms. If we're only going up to the polynomial of 3, you only have to go up to the third derivative. Now, we don't care about what these are as functions of x. What we really want is we want to know what all of these values are when we plug in 3. So f of x is equal to 1 over x means that f of 3 is 1/3. My first derivative at 3, plugging 3 into that, I get negative 1 over 3 squared, which is 9. The second derivative, plugging in 3, we're going to get 2 divided by 27, it looks like. Third derivative, plugging in 3, something's awful. Negative 2 over 3 to the 4th. Is that 81? And then 81 divided by... Is it just that? It's got to be. All right, negative 2 over 27. I should really start bringing the calculator up here to do these. Okay. Oh no, Josh has lost sound. Maybe you can follow. So the piece of 0 is just going to be the first term of the Taylor series when k is 0. If I plug in k to be 0 in all of this stuff, it's just going to be the function as is at 3, which is the 1/3, that divided by 0 factorial times x minus 3 to the 0. Now 0 factorial is just 1, and of course anything to the 0 power is 1, so that's just going to be 1/3. And that's all it is. So the piece of 0 is just the first coefficient of your series, for us 1/3. The next value, piece of 1, is going to be the polynomial of order 1. It's still going to have that constant out in front. Plus, it's going to have the next term. The next term is going to be the first derivative at 3, which is the negative 1/9, divided by 1 factorial times x minus 3 to the 1 power. So just to simplify that out, we got the 1/3 out in front. It's going to be a minus 1/9, and then that times x minus 3. So that would be this next one. Cool. 2 more of these things. So piece of 2 would be that thing, the first 2 terms, so 1/3, a negative 1/9, x minus 3, plus second derivative of stuff. So that's going to be the coefficient 2/27 divided by 2 factorial times x minus 3 squared. And then that, of course, would simplify down to be 1/27 x minus 3 squared. So that would go here. Oh man, fingers are getting tired. Typing all this out. But does that make sense, right? So we're basically plugging in the Taylor polynomial, but term by term. And then just adding on each of the next terms here. So here would be the first term, here's the first two terms, p sub 2 would be the first three terms, p sub 3 would be the first four terms. So it would just be this, and then you would subtract by the third derivative at 3, negative 2 over 27, divided by 3 factorial, and then x minus 3 all cubed. And copy paste. So p sub 3 would be all of that stuff minus the 2 over 27 divided by 3 factorial times x minus 3 all cubed. 227 divided by 3 factorial is going to be 1 over 81, I think. Can I copy paste from here? No, of course not. Cool. Yeah, so I know all these different variables are kind of confusing, and it's going to take some practice to get used to the Taylor's polynomial, doing the derivatives, finding the derivatives at the constant, at the center. That goes into the numerator divided by the factorial, and then you keep increasing your binomial here by whatever k value or n value that you're at. Was that? I know Josh was the one that asked the question. So, does that make sense? Is that okay?
Yeah, I think it does. The hardest part is just like, getting past the different variables.
Right.
Do you have any tips to how to keep it organized?
Well, not like I did, but
Like in columns or something?
oh yeah. So what I would probably do, I mean, I kind of did it like as I went. I would just figure out what the first term is. So I would do something like, okay, at k equals 0, I'm going to have my 0th term, which was just 1/3. And then when k is 1, I'm going to have the next term. That one ended up being the negative 1/9 x minus 3. So all of this stuff that I was doing over here would just be on scratch paper. And then, down here I would kind of have it all as organized as I can with the different term values. And then you're just adding up these individual term values. And then, so like I have up here, that this would be in a column as well. It's so hard to do it in Word, but I wouldn't write this out horizontally. I would have written this all out vertically instead. Does that make sense? Does that help?
Yes, sir. Thank you.
Yeah. I'm not the most organized person when it comes to writing out math stuff. Because in the first place, and now using Word instead of using something I can actually write it all out in, it makes things hard.
Neither am I. That's why I'm asking. So, yeah, thank you.
Yeah, I mean, just to try it. I can't even type right now. Anyway, I hope you kind of get the idea. And then you would just keep building onto this. So then the second one would be the derivative. So then it would be f prime at x would be the derivative. And then you'd want to plug in 3 into that. And then you'd want to, find the next term of the Taylor series over here. And so on and so forth. Trying to separate them into columns. And so when I'm working on it on my own, this is kind of how I try to organize it all up. Take up some time though. Is there any other questions you guys want to look at? I will be doing 2 more of these next week before the test. So if you guys have some more questions between now and next week, we can also look at them then. I'm going to try to put up like a practice thing as well next week, just so you can kind of get a general idea of what questions are going to be on the test. And then, if you have questions from that practice thing, we can look at that during these meetings next week as well. I'll try and get that up tomorrow maybe. I'll have some time to sit down and make that. Last call though, any other? I'm going to ask Josh too. Any other homework questions you want to see now? All right, cool. We'll probably just call it there then. So I hope you guys have a good weekend. Make sure you keep working on the stuff. 7, 8, 9 will probably be the hardest sections out of the bunch. But if you have any questions, you can always email. I'll put this recording up so you can watch that, and you can start working on the Chapter 11 stuff here pretty soon. Unless there's any last questions you guys have, let's just go ahead and end it here.
Okay, sir. Thank you. I really appreciate it.
Yeah, of course. Anytime. All right. I'll see everybody next time.
All right, see you.